All right, here we are. We're going to talk quickly about what a geometric sequence is, as well as the notation that is attached to a geometric sequence. So, first and foremost, a geometric sequence is just a sequence of numbers that has a pattern, a recursive pattern, where each previous number is multiplied by some r value to get the next number. The first thing you need to know how to do is how to find r. Sometimes you can look at a sequence and say, well, I'm looking at this, and from each number to the next, it's doubling. It's timesing by 2. If you have the previous term, you just times it by 2 to get the next term. That timesing by 2 is the common ratio, is what it's called. Sometimes it's not easy to see the common ratio, and so you actually have to calculate it. And there's a couple ways to do it. You can keep in mind that, if you take your first term and you multiply it by something, which we're calling r, that product will equal the next term. And you could do this with any of the terms. If I take 6 and multiply it by some r, it's going to equal 9. And if you solve either one of these equations for r, you get 6/4, you get 9/6, you end up finding that r is 3/2. That's one way to find r. Another way to find r is you can just take the ratio of consecutive terms, 6/4 or 9/6. And so it's kind of the same thing here, done in two different ways. And so if a sequence has a consistent r that it gets applied every time, then it makes it geometric. Okay, a couple things also. So r you can kind of think of as the pattern. In this case, r is 3/2. The next thing to think about is these terms are known as a sub 1, meaning the first term in some sequence, a sub 2, a sub 3. When I say sub, I mean subscript, a sub 4. And then the sequence can go on and on as long as you want it to. And if you had the previous term, like 27/2, you could just multiply by r. In this case, r is 3/2, and get the next term. But if I ask you to find the 8th term, 9th term, 100th term, there is a formula for a geometric sequence that will always work. And it's classified as the nth term, meaning any term you want, is equal to the first term times your ratio to the n minus 1 power. And so I just want to show a quick demonstration on how to use this formula. And maybe with this sequence, we'll find a to the 6th. So what this means is, what is the 6th term of this sequence? And so we can find it by taking the first term, which is 4, finding the rate, which we already found, or the ratio I should say, which is 3/2, and then taking it to the nth power. This is n 6 minus 1 power. And if we simplify this a little bit, it becomes 4 times 3/2 to the 5th. And picking up the pace, we have 4 times 3 to the 5th over 2 to the 5th, which is 4 times 3 to the 5th is, what is it? 81 times 3, 243 over 2 to the 5th, which is 32. Again, we're finding a to the 6th. And I don't have a calculator handy, but I can simplify this fraction. 4 and 32, that becomes an 8. And so the sixth term would be 243, 243 over 8. And I accept improper fractions, so you could leave that as an answer. But if we kind of do it the old-fashioned way, what this means is if I take, 27 over 2 and times it by 3/2, I would get 81 over 4. That would be my fifth term. And if I, times it by 3 over 2 again, that's my rate. 81 times 3 gives me 243. And 4 times 2 is 8. And just notice that that would give me my a to the 6th. So you can actually find it multiple ways. But if this n value gets pretty large, you do want to have this committed to memory, because that will give you the nth term of any geometric sequence. All right, thanks for watching.